continuing to look at complex numbers today, and the first thing we're going to do is use the Moivre theorem to show our double angle formula for sine and cosine. So if we consider the cosine of 2 theta plus I times the sine of 2 theta by the Moivre theorem, this is equal to cos theta plus I sine theta squared, and that's equal to cos squared theta plus 2 I cos theta sine theta, just from expanding out this bracket, and then plus I squared sine squared theta, but I squared is -1, so minus sine squared theta. And just like when comparing the coefficients, with complex numbers, the real and imaginary parts on both sides of an equation have to be equal. So if this is our left hand side and side, well, the real part here is cos 2 theta, and the real part here is cos squared theta minus sine squared theta. So we can write that cos 2 theta is equal to cos squared theta minus sine squared theta, and the imaginary part of the left hand side is sine 2 theta, and this is equal to 2 cos theta sine theta. Okay, so these are a familiar double angle formula but found through the Moivre's theorem. Now the final thing we're going to look at in this video is another little result you should be familiar with. If z is equal to cos theta plus I sine theta, then z of n is equal to cos n theta plus I sine n theta, as I'm sure you're familiar with by now, and z to the power of minus n. Well, this is equal to cos minus n theta, but cos is symmetric about the y-axis, so it's an even function. So that means that this is still just cos n theta, okay, because cos minus n theta is equal to cos n theta, and sine theta is odd, which means that sine minus n theta is equal to minus sine n theta. Okay, if you just think about the graphs, this will make sense. So now, adding up Zn and Z up minus n, well, these sine terms cancel each other out, and we just get 2 cos n theta, and then subtracting these just gives us 2I sine n theta. You see, if we subtract them, these cos terms cancel out, these double up. Right, so you can see now that we've got some formula here for finding cos and sine theta, where theta is multiplied by some n. These are quite useful. Just a reminder that for this to work, z is equal to cos theta plus I sine theta. Okay, so hopefully this result makes sense, and you've seen a few uses of the Moivre's theorem. If you do have any questions, please be sure to let me know in the comments. If you did find this video helpful, please support me by subscribing and liking this video, and I hope to see you in the next one.